Hi, and welcome to my lightning talk. My name is Christopher Sterpka. I'm from the University of New Hampshire, and I've been collaborating with the LOFAR lightning group in the Netherlands. I'm here today to tell you about lightning initiation studies we've been doing with using beamforming on data from the Dutch portion of LOFAR. So the question we're looking to address is what is really happening in the first few moments of lightning initiation using the detailed possible forming with LOFAR. So the two major theories we're looking into are the Griffiths and Phelps model, which is pictured on the left, and the Giervich runway electron avalanche model, pictured on the right. The Griffiths and Phelps model, what happens is a streamer discharge forms on water ice particles causing perheating, which leads to the formation of lightning. And then in the Giervich model, cosmic rays or other seed particles interact with the high fields in a thundercloud, generating heating, resulting in the lightning discharge. So here we're using interferometric beamforming in 3D to study lightning. We're the first group to do this, and as a result, we're actually starting to unfold some of the mysteries of lightning initiation. Here I'm showing an example time trace of an initiation event. The top plot, the red trace is a signal from a single antenna. The green is a sum spectrum resulting from beamforming. What we're finding is a strong reduction of noise baseline and the detection of features that are not otherwise not visible. From this, we can ascertain dynamics of sources in very short time scales, talking about an order of microseconds. You need to imagine this is very important for lightning to be able to do this. The time scales of the particular events we're looking at are very short, in the order of 15 to 20 microseconds. So here's a real image of an initiation event. Note that the images are in fact 2D slices of a 3D cube. It's essential to locate these events as precisely as possible in space and time in order to be able to understand what's going on in these first few moments of the initiation process. No previous results have been able to do this with this level of detail. Typically, they were 2D images with lower resolution and fewer antennas. Here, I'm showing the VHF power ramp up on the left and the velocity on the right. And as you can see, we have a very exponential ramp up. The blue line is the VHF power, and the red is a exponential pitch. The green regions correspond to the timing of the images from the previous slide. The VHF power ramps up by background by 2 orders of magnitude in 15 microseconds, and then there's a slight ramp down followed by an impulsive source. On the right, the source propagates with a linear velocity of about 4.8 times 10 to the 6 meters per second. And the punchline here is that the velocity is constant during the exponential ramp up, but also during the ramp down. It's not exactly clear how this would be the case. So what we think is happening is starting with a single upward propagating discharge known as a streamer. This produces the first visible VHF signal above background. The streamer branches and grows multiple times while propagating nearly 100 meters. That's pictured in the middle. Ultimately, this results in channel feeding in the formation of the main leader, lightning leader, within 10 meters of the location of the first image streamer. You may recognize that this is very similar to the Griffiths and Phelps model mentioned at the very start of my talk, but the main difference, what we're seeing is the exponential growth paired with the linear propagation velocity. So there's more to come. We're investigating additional flashes with a new analysis engine, including a more precise antenna model and a polarization model. And so we're picking up weaker sources with greater precision and simultaneously polarization outputs. And so we're seeing similar structures in more recent data sets. If you'd like to know more, the manuscript is available online now, and there's a preprint available. Thank you for your time.